Okay, so welcome back. Today we are going to show you how in C++ to import 3D objects into your raytracer, whatever software you're developing. We showed in a previous series on 3D raytracer in C++, and in the last video in that series we were looking at how to import objects, and we found some open source software that kind of does the job, but in looking at the software, we came out with some of the shortcomings that I find in open source software, and one of the reasons I try to avoid it, if at all possible. And the problem was the documentation wasn't very good. The naming conventions for the variables made it very, very difficult to understand what it was doing and reverse engineer it. And this is a task that's really not too difficult. So what we're going to do in this video is we're going to show how to write our own importer for 3D objects into your 3D ray tracing software. And it's also an extension of a recent video I did where we showed how to import what's called a CSV, or comma separated value text file, that you see often in the engineering world, where you've got numbers separated by commas, and we showed how to import that so that you can then plot the variables and whatever. So this is kind of extension, adding the functionality of that code to be able to import and parse 3D object files. So what we're going to do is we're going to use a very simple object file, and this is using one of the features we talked about previously in Visual Studio, where you can double click on a .obj file and it will show you the file, and you can edit it and you can do a bunch of things with it. So I encourage you to look at the previous videos. We're going to look at this very simple file of this cube object, and it's only got 6 faces, and we're going to see how to import that file. Now here is the very simple text file called the .obj file, or wavefront object file, that fully defines this cube. And you can see it's got 8 vertices and some texture coordinates and some normals and some faces. It's got 6 faces, which you can see on this cube. You got 6 faces. And this fully defines to your ray tracing software that object. So if you look at this, we're going to basically import this file, and once we know how to do this, it's going to automatically be able to do it with very, very large complex files. And we're going to figure out how to parse this and make vectors of all these numbers so that we can then bring that into our ray tracer and use it. So what we did in the previous video on CSV files was we showed how to import a text file like this and put each line of the file into a vector of strings. So what we're going to do is each line of this file, we've got 40 lines, and each line is going to be one element of a vector of strings. Okay? So then once we have a vector of strings, we can say, okay, I've got my vector of strings that have a V to define vertices and some numbers following it. So then I can say, okay, if it's a V, I can parse it a certain way. If it's a VT, I can parse it with 2 floats, and if it's a VN, I can parse it with 3 floats, and if it's an S, I can parse these complex numbers. But really, it's basically doing what we did in the previous video on CSV files and building a vector of strings representing all the lines of this file. Once we have that, we can then go, and we're going to do that in this video, we're going to start parsing these into usable numbers, and we're going to parse all of these into vectors of numbers. Fairly simple task. In many objects you're going to use in Blender or whatever, you're going to have many, many, many more lines to define many more faces and parameters of the object. But we're going to start out with a very simple cube that helps us to debug and to make sure we get the right numbers, and then that will expand to using very large objects. So here is the code that I have that has this additional functionality of being able to import and parse these .obj text files, okay? And much of this is already here from our previous video where we did CSV files. And I've got it set up as I normally do with my code. This CPP file contains just about everything we need, or actually has everything we need. I have no separate files for classes or anything else. That can be in the future, but to make it simple, I've got one file. You can see over here a bunch of files. Those are just that I can access if I want to read them in as OBJ files or CSV files or whatever. These are just here for me to read in to do any debugging. So again, this is all the code. I've got my includes, and these are the same includes we had from the previous CSV. So I encourage you to look at that. To do, I always have a to-do list and documentation. Here I have added a simple class called the face class. And it has a bunch of vectors of ints. So what we're going to do now is jump over and look at how we're going to design this code and how we're going to bring all this data in, how we're going to parse them into different types of vectors. Because you can see based on the type of line it is, it's going to have different, this is going to have a vector of 3 floats, and this is going to have 2 floats, and so on. Here's our file of our simple cube. And what we're going to do is we're going to, again, we've got vectors of strings. Each line is a string, and it's going to be in a vector of strings. And we're going to take that long vector of all these strings and parse it by looking at the first character or the first 2 characters in each line. After this text descriptor, there's a space. So we can use the same function we used in the previous video called getLine and say, hey, what's the first character before the space? Or the first multiple characters, in this case 2 characters before a space. We can then parse these and put them in their own vector. In this case, we're going to have vectors of 3 floats each. And we're going to have other vectors of 2 floats. So if you look over here, this kind of explains how we're going to lay this out. We're going to take these that start with a V, and it's called the vertices, and we're going to convert them to a vector of vectors of floats. And it's going to be a vector of 8 vectors with 3 floats each, okay? 8 vectors with 3 floats each, and we're going to call them vertex positions. The next one is texture coordinates. You can see we've got 14 lines, and each has 2 floats. So it's going to be a vector of vectors of floats. So 14 vectors of 2 floats each, and we're going to call those texture coordinates. Then the normals, we have 6 vectors of 3 floats each. So a vector of floats, and we're going to call it normal vectors. And then the more challenging one is these faces. This describes, as I've talked about before, the indices or the numbers of these lines of vertices and normals and texture coordinates that define a face. So we have multiple things in here. There's the first, before the slash, is the vertex. Which vertex? So number 1 is this first vertex. The second one is the texture coordinate. So number 1 is the first texture coordinate. And this is the normals, which is number 1, which is this first normal. We're going to parse those into indices, and each one of these numbers is an integer index. And we're going to make the indices, in this case, 24 by 3. So 1, 2, 3, 4 groups by 6 faces. So that's total of 24 groups of 3 indices. So here's a group of indices, here's another group. And that will be a vector of unsigned indices. We'll call it indices. And then we're going to have a vector of faces, 6 vectors of faces that describe each of the 6 faces with all of these sub numbers. And to do that, we're going to make, as you saw before, we're going to make a class called face, and it's going to hold all of this data of all of these separate types of indices. And we're going to push all those into a vector called faces. So each faces vector has 1 line of data with all the sub numbers. So let's go back to the code and see where we are. So like we said before, we've got a class called face that is storing a vector of ints called vertex indices, which is the first element. As you can see here, the first element of each group are the vertex indices, then the texture indices, which is the second element of each group, and then the normal indices, which is the third element. So we're storing all of these indices in a face class, and so each line is 1 face, and then we will push those back into our vector and get a total of all the faces with all this face objects inside, okay? So that's our face class. We're going to instantiate that. To initialize, pretty simple. We've got this vector of doubles we use for our CSV files, which basically has the output of the X values and the Y values. We're only adding to that for our OBJ file these vectors of floats, vertex positions, texture coordinates, and normal vectors, okay? So it's basically going to be the vectors of these numbers for the vertex positions, and then the texture coordinates is all of these in a vector, and then normal vectors is all of these, all right? Then we're going to have a vector of vectors of unsigned ints, which is the indices. And that's going to contain all of these indices that we can then parse, all right? And then we have a vector of face, our face object, which is called faces. So each time we have a face, we will push that into this vector and we'll have all of the faces. So that's the initializing, really not much to it. Then we've got a bunch of methods we'll talk about in a bit, and then our main function. This is pretty straightforward. There's not much to it. I'm using a lot of methods for this because it's a lot cleaner. But to start out, I do std string file name, and I'm going to start out with cube.obj, which is this file we talked about before. I'm also defining a vector of strings called record string. And again, that is a vector of all of the strings of all of the lines in the OBJ file. So that's what we're getting from the previous video when we did the CSV. I think I called it CSV records, but basically it's now more generic, so it's record string. It holds all the records in string format. This is what we did in the previous video. We basically have this record string, and we call this read from text file, and we feed it this file name. So here's our method read from text file, and we feed it the path, and we go through and check if there's an error. We do the read buff, and we basically do all of that, and it prints out how many records were found. And that's about it. So this is from our previous video. You can take a look at that. Pretty straightforward, just getting a vector of strings. So once we have the vector of strings, what we can do is I am just extracting the last 3 characters of the file name. So in this case, it would be the OBJ, or if it's a CSV or a TXT, so that we can recognize what type of file suffix we have. Not really necessary, but I'm just using that so that we can say, if the file suffix is OBJ, then parse the OBJ. If it's CSV, parse the CSV. Otherwise, if it's like a text file that we're not going to parse, you have an output due, and I'm like totally not prepared for that freaking TXT or whatever file. So here is what we would do for a CSV, parse CSV to double we talked about before. This is all we're adding is the parse OBJ. We feed it that vector of strings. And then I've got another method I'm adding to print all that OBJ data based on what we want. So the real worker here is this parse OBJ, and we feed it that vector of strings. So let's take a look at that in our methods. Parse OBJ. These drop downs are just comments. As you can see, we feed it the vector of strings of all the records. And what we're doing is we've got in here some internal counters and incrementers that kind of throw away values. A vector of ints called vertices per face, so we can determine whether they're triangles or quads. And then one integer, verts per face. So each time we find a face, find out how many verts, and then we push it into this vector so that we have, for each face, we have a number on how many vertices. And then num faces just keeps track of how many faces. We also have intermediate string values. So each time we parse this CSV, we're going to go through and put values into a string or into a vector. They're kind of throwaway values that we're going to use for each set of parsing. So we have a string called value and a vector of string called values. So that's just intermediate stuff. We also have some intermediate numerical values. So we have a vector of floats called vertex position, and then texture coordinate and normal vector. So as we loop through each of these, for example, this vertex has these three to define a position. That's going to go into vertex position. And then at the end of the day, we're going to push all those into vertex positions, which has a summary of all of the vertices. All right. So these are kind of intermediate individual numerical values. And that's it for the initializing. I've got some more comments. But here we just go through the input record string and parse all of the values. Okay, I think I'll save the details of the parsing code for part 2. Right now we have a console application where you can see it reads in our cube object, and there's 40 records, 8 vertices, 6 normal, 6 faces, and then it tells us for each face, each of the 6 faces in the cube, there's 4 vertices, and so we can pull out whatever data we want to give a summary of the data we read in. And again, all we have to do is change the file path and it will read any of the others. So if you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, and most of all, let others know that we're here so we get some views. Otherwise, take care. Have a really good day. Thanks.